We have a cube with edge length A. The ground is rough. Initially, it's given some velocity. So it travels over some distance and comes at rest. Not this diagram. just, just imagine that you have a cube. So if you slide it on a rough surface, it will eventually come to rest. Explain the disappearance of angular momentum relative to the axis lying on the plane. So for example, you have this axis P, so that's going inside the plane. So with respect to that axis, initially it has some angular momentum, that is mv into a by 2. And finally it is at rest. So final angular momentum is 0 about P. So how come the angular momentum disappeared? And find the distance between the resultants of gravitational forces and the reaction forces. So the hint of the first part of the problem is given in the second part of the problem. That normally when the block is at rest, the gravitational forces and resultant of normal reaction, they lie on the same line. But here it's saying find the distance between resultants of gravitational force and reaction force. So we assume that mg and n, the resultant n, are not on the same line. And it's actually it wants us to find this distance x. So yeah, let's assume that normal reaction is passing through the center as expected of a block which is at rest. So let's see what happens if that is the case. So if that happens about this point center, so there will be frictional force towards left. And if normal is passing through the center, then this frictional force will rotate the block. So the block should start rotating, but it does not rotate. It slides. That means the normal reaction cannot be at the center. So where it should be, towards left or towards right? So if it is towards left, again about O, the net torque will try to rotate it. So normal reaction cannot be towards left. So it must be towards right. So it must shift towards right. So it counters the torque due to the friction. So now we can imagine this is the scenario where the torque due to this friction is countered by torque due to this shifted normal reaction. And that's why it's not rotating about its axis O, and it will just slide. So that is our first, that is the reason of disappearance. Actually, not the reason of disappearance. We have just discussed why the normal reaction should shift towards right. So therefore, n shifts, providing counter torque and prevents that rotation. Now let's take this point P, that is so that's an axis that is lying inside the plane. And about that, initial angular momentum is mv into a by 2. Because the center of mass is traveling with a distance v at a distance a by 2. And it's not rotating about center of mass. So the angular momentum of this whole body about point P right now is mv a by 2. And finally it comes to rest. So Lp is equal to 0. So now we can conclude that the initial angular momentum, see what forces we have is frictional force that is passing through point P. Then we have N and mg. And we know because it's not traveling up or down, N must be equal to mg. So now you can see about point P, the net torque on this block is counterclockwise. Its angular momentum is clockwise because of the velocity v. And because of this N, which is same as mg, and it is at a greater distance, so that N is providing a counterclockwise torque that is reducing the angular momentum of this whole block about point P. So hence Lp disappears as cube comes to rest at B as torque due to N neutralizes it. So a lot of concepts here. I'll quickly give a brief recap what's happening. So if mg and n were in the same direction and then it cannot slide, because then about O it has to rotate. The torque due to this frictional force will rotate this. So it does not happen. That means N must shift towards right. And if N shift towards right, then about this point P, you can see that because this is also mg and N is also mg, so the torque of this mg is greater than torque of this mg, because this force is at greater distance. So hence this counterclockwise torque will neutralize the clockwise angular momentum. So initially this block does have an angular momentum about point P, but this counterclockwise torque will neutralize it and it will eventually come to rest. Now we need to find the distance between the mg and N, because between the resultant of gravitational forces and the reaction forces. So we are going to do this quickly with 3 different methods. And it's not that one method is better than other. It's just you will get some conceptual clarity when you will see all the 3 methods. So with respect to center of mass, we can do that. So we know that cube does not rotate like this, which means tau about O is equal to 0, which means N into X is equal to F into A by 2. So N we know is mg and F we know is kmg. So that gives X is equal to Ka by 2. That is our answer. So this we got the distance of X by writing the torque about the center of mass. Now let's find the torque about a general point P on the plane. So we know torque is rate of change of angular momentum. So if we are writing about point P, let's take the clockwise sense as positive. So torque about point P is positive. It's in counterclockwise sense. So that we can write as mgl minus, so the torque because of the mg will be mg into L minus N into L plus X and dl by dt. So what is the angular momentum about point P? That is mv into A by 2. So this L is positive because in our sense we have taken the inside direction as positive. So we put that value here. So we get ma by 2 into dv by dt, and we know dv by dt is minus kg. So why minus kg? Because we are assuming the direction of v to be positive towards right. So then dv by dt, due to the frictional force, will be towards left. So that will be negative of what assumed direction we have taken for velocity. So that will be minus kg. So be very careful. These signs are different. So this negative sign has nothing to do with this direction. This negative sign has to do with direction in x direction. So yeah, we write this, we write N is equal to mg, and we just simplify and get X is equal to Ka by 2. So like I said, it's not that this method is easy, but to get a complete conceptual clarity of how we can write tau p is equal to dl by dt with appropriate signs, this method is important. Finally, with respect to point of application N. So let's take the torque about this point, because here 2 of the forces are getting disappeared, N and F. So again about this point we are going to write tau about point Q is equal to dl by dt. So dl is again mv A by 2. So mv into A by 2, this distance about point Q. And torque about point Q will be only because of mg. And now you can see, because we have taken inside direction as positive, the torque of mg will be negative. So we have to write minus mgx. So ma by 2 into dv by dt, and dv by dt is again minus kg, because this is negative. The direction of dv by dt is negative to the direction of v. So again we will get the same answer, Ka by 2. So yeah, that's about it.